to stop and check, because you should be able to do all of them. It will be recorded, though. Then we're going to move on to actual factoring. Oh, I also wanted to do a test reminders thing, because you have that in your book. Yeah, you got the page for that. We'll do that. We'll do that at the very end of today. So it's the last thing you see. Well, you can always do the long cut.
Yeah, but that's not as convenient, is it?
It is not as convenient. No, that's why they're called shortcuts. Add the, hey, Bryce, you add the constants.
I get how to do it. It's like, no.
So
No, I got you now.
You sure?
Yeah, no.
Okay.
I figured it
Add the constants to get the linear term, multiply the constants to get the constant term. So this is x squared plus 7x plus 10. Yeah, add them to get the linear term, and multiply them to get the constant term. So this next one's going to be x squared minus 5x minus 24, and so on.
There we go.
Now that boggles or gums you up a little when you get to G and H. None of that should be news to anyone. Everybody should be able to do that. Obviously, it will probably take you a little bit longer, and some of you may be breaking out your calculators. That is fine, because adding and subtracting negative numbers sometimes messes kids up. Remember, it is not a race. I do not care how long it takes you to do this. But to understand factoring, you really got to be able to do this, because factoring is just the reverse of this. Just like division is the reverse of multiplication. It'd be really hard to learn division if you don't know your times tables, right? So I'll give you a moment to make sure you're all caught up on that, and then we'll move it along.
is there even a shortcut for those? Because I'm looking at
For which ones?
For the G and H, I'm looking at them. I can't really see a pattern. Besides, like,
There is. I have never bothered to learn it because I just do 3 times 5 is 15, 2 times 5, 2 times 1 is 2, 15 and 2 is 17. By the time I remember how to do the shortcut, I could have done it regularly. And I often find myself, like, we're about to do something this year that you guys haven't seen before, that when you use the shortcut, I hate it. It really causes me problems to remember exactly how to use the shortcut. So I choose not to. And then, because I don't use it, I don't remember what it is. Like, I was shown this shortcut when I was in the 11th grade. I hated it then, so I don't use it now. Right? And I apologize. I just don't remember it. I mean, I could look it up, but I just find it easier to just distribute it out, right?
The other parts are pretty much the same. So
Yeah.
it's just as easy.
Right? I mean, you know it's going to be 10 at the end and 3x at the beginning. And then, like, it's just easier for me to do it that way. I'm sure there's a shortcut, but I don't know it, so I don't teach it. I'm actually going to ask some of you guys, there's a way to factor these that is a way I don't ever use, and I can't remember how to do it properly. But somebody in this room has been showed it, so I'm going to ask them to show it anyway, because I don't remember how to do it.
Probably the way I was originally taught that I didn't like.
Everyone's okay? Everyone can expand? Yes? All right. So let's turn the page over and let's review actual factoring. Remember, factoring is simply the reverse of distribution. Okay? Or expansion. There's 3 types. Okay? They're all, well, yeah, there's 3 types. The first one is GCF. GCF is very important because we always want to try this first. Always, always, always try GCF first because it makes things simpler. And GCF factoring is always the same thing. One, you decide on the GCF. 2, you divide. And 3, you write the answer as such. GCF, bracket, and then all the quotients that you got. Quotient 1, quotient 2, and so on. Okay? As soon as you, if this makes no sense, you don't worry, because as soon as you see it, you're going to remember how to do it. So, step 1, decide on the GCF. What's the GCF of 6 and 3? If you're bad at GCF, I don't know that right now until later. So as of now, I'm going to assume you can all find GCFs fairly well. If you can't, I'll do a little mini lesson on that. But you really should only need it when the numbers get really, really big. Okay? So what is the GCF of 6 and 3? 3. So, step 1, I've chosen my GCF. My GCF equals 3. Step 2, divide by the GCF. Divide by 3, divide by 3. Step 3, write it out. The GCF first, 3, then all my quotients. 2x plus 1, bracket, done. Everybody is good, yes? That's the easiest one. Now, again, nothing changes. What is the GCF in number 2 in B here?
2x.
Okay, 2x. So then I divide everything by 2x. And I write it out as GCF, then the quotients. 2x plus 3. Is everybody good? Do I need to do another one that looks like these two? Or is everyone okay? All right. Now, obviously, there's a lot of blank space there. The reason for that is because this can get difficult. I'm going to do 2 more examples that you're going to have to think about a little. Okay? How would you factor that? Lucas. You could distribute it first. Please don't. You could, but please don't. Who else has an idea? Kelvin. The GCF is x minus 5, right? Because that and that are the same. So, if you don't see that, I'm going to give you a little shortcut that I like to give. I choose another letter. A equals x minus 5. Everybody understand? So this is really 3a minus 5a. Now you can quite easily see that they share a factor. Does everybody understand? So the GCF is x minus 5. Then everything else just goes normally. I divide both by x minus 5, and then I rewrite as x minus 5, and then the quotients, 3 minus 5. What is 3 minus 5? Negative 2. So this is x minus 5 and negative 2. Cool? Everyone is good? Yeah? Okay. Then what do I do if it looks like this? 2x, x minus 5, plus 3, 5 minus x. What would you do, Bryce?
Multiply by negative 1.
Not multiply.
Or
divide by negative 1.
Sorry.
To which factor? The one on the left or the one on the right?
Do the one on. Oh, I think the one on the left. Okay. Dude, you messed me up.
Bryce, let me help you out. Would you divide the yellow one or the blue one by negative 1?
Purple.
The yellow one or the blue one?
Well, my first one I was thinking multiply was blue, so.
Yeah, you would use the blue one. And you would rewrite this as what? 2x, x minus 5. Now, if I divide that by negative 1, because 1 is a factor of everything, isn't it? What does that turn this positive 5 into? Negative 5. And what does that turn this negative x into? Positive x. And what does that turn this positive 3 into? Negative 3. Now my GCF is x minus 5. And the other factor is what? 2x minus 3. That's about the most complicated GCF one you can do. Is everybody okay to there? Going once. Going twice. Yes, Calvin. You could do the same thing with the other one. Yeah, because then you'd get it positive 5 and a negative x and a negative 2. So it would be just 3 minus 2x. And 5 minus x. Okay? Everybody cool? I didn't get to going thrice. Going thrice.
Going Bryce.
You're always going Bryce.
True.
Okay. Trinomials. First one, you already know how to do it. It's the reversive distribution. Now, since there is no leading coefficient, we know that when I distributed this, there's a shortcut. The shortcut is you add the 2, then you multiply the 2, right? So here you go backwards. You need two numbers that will multiply to 7 and add to negative 8. What are they? Negative 7 and negative 1. So it is x minus 7, x minus 1. Now, we'd already reviewed that in our last unit, yeah? Everyone's happy with that? Everyone remembers how to do that? All right. What's weird about the second example here? There's a coefficient out front. How do we get rid of it? GCF, always, because you're going to GCF first every time, right? So you're going to divide this by 3. Now, here's the mistake you guys are going to make. You're going to forget about that 3. Because what this is really 3x squared plus 6x minus 8, right? You're going to forget that 3. Don't. Because now I need to multiply to negative 8 and add to 6. What is it? You want to say 4 and 2, don't you? But that doesn't work, does it? Right? So now this is where I tell you, learning how is not the right thing here. Because you want to put 4 and 2. And some of you are going to write 4 and 2 there when I give this question to you on a test. It won't work. This does not factor anymore, does it? But if I change this to positive 24, now does it factor? Now what is it? Now what is it, Sid? If it's positive. Now it's 4 and 2. X plus 4, x plus 2. Is everybody good with those ones? Kelvin? Yeah? You would leave it here. That's done. That's all the factoring you can do with it. Okay? That's very good point, because a great many of you will try to factor when you can't. That's kind of like doing a science experiment and having an idea of your results and what you want your results to be, and then trying to design the experiment to get those results. Right? That's stupid. You do the experiment to get results. You don't get results and then figure out the experiment. All right, so as always, just like we did before, I'm going to draw a line and we're going to show you where this could go. All right? The next thing that happens with this is exactly what happened in the top one. What if I gave you something like this? X minus 5 squared plus 7 x minus 5 plus 12. If I gave you that, what would you do?
I'd do it out.
So you would distribute all that out and then collect your like terms and then factor.
Well,
I'm not saying that's wrong, Bryce. That's what you would do. That's why I asked, what would you do? You would distribute all that out.
I can see the way to do it quickly. So.
Yeah. What should you do? Now.
Oh, wait.
A, right? And now all of a sudden I have a squared plus 7a plus 12. And that I can factor in my sleep, can't I? That's a plus 3 and a plus 4, yes? But a is not part of the original equation, is it? What is a now? X minus 5 plus 3 and x minus 5 plus 4. So it's really x minus 2 and x minus 1. And that's where you're done. Is everybody cool with that? Yeah? Now, if you cannot wrap your mind around this, then go ahead and distribute it out. It will take a long time, but you will get the right answer if you factor correctly. Is everyone cool? Is there anybody in the room that wishes to see this distributed all the way out and prove that it works for yourself? Or are you all okay with this? First block of the morning. We're all good? Okay. Difference of squares. This one causes people problems, and I really don't know why. A difference of squares, couple of things. One, the important word here is difference. What does that mean? It's subtraction. This only works with subtraction. And it is anything squared minus anything squared. As long as it's squared, this works. Okay? And I'm going to give you an example first. X squared plus 0x minus 9. If you were to factor that, you need numbers that multiply to what? Negative 9 and add to what? 0. And what are they? Negative 3 and positive 3. So this is x plus 3, x minus 3. Yes? But I would never write this, would I? Because what is that trinomial actually? X squared minus 9. Which gets me a squared minus b squared. Because 9 is a perfect square. Is everyone cool with that? So we'll start super easy and make sure everyone's okay. We're going to do a bunch of these because this has weird things happen with difference of squares. First one is this. X squared minus 64. What's the factors? X plus 8, x minus 8. Everyone cool? Easy peasy lemon squeezy, yeah? Okay. B. 4x squared minus 64y squared. What's that? I've trapped you all. Please notice that when you factor this out, you get the square root of the first one plus the square root of the second one. Then you get the square root of the first one minus the square root of the second one. So what is the square root of the first term here? 2x. Plus, what is the square root of the second term? 8y. And then you get the same thing. Is everybody okay with that? Lucas? Yes, which is what I'm about to do next. Because you can't always simplify first. Okay? All right. I lie. You can't always simplify both terms first. You'll see what I mean right now. Okay? 3x squared, no. 3x cubed minus 27x. What should I do? This is just what you asked about, Lucas. What should I do? Take out a 3? 3x. And that leaves you with x squared minus 9. Now what? 3x and square root of the first one, x, plus square root of the second one. Is everybody okay with C? Everyone is good with C? Going once, going twice, going thrice? Yes? All right. Now that leads me to D, which I want some more space for. X minus 4 squared minus x plus 7 squared. I'll let you think about it for a moment. Talk to your neighbor if you need to. I've given you one strategy that would help you solve that. There are 13 people in the room that I guarantee know how to do that. Yes? You weren't in my class, so I can't guarantee that you know how to do that. Oh, Joel knows.
Oh, yeah, but...
So does Bryce. So does Lucas. Actually, Lucas, I can't guarantee it. Lucas I taught in grade 9, not grade 10. Damn! I had to lower it. What should I do with this? Or what could I do with this? Can I make that A? Can I make that B? So then is it A squared, B squared? What's the square root of A squared? A. So this must be A, x minus 4, plus, what's B? X plus 7. And then the next set of brackets is the square root minus the square root. And now what must I do in there? What must I do there? Collect like terms. X plus x is how many x's? 2x. Negative 4 plus 7 is what? Plus 3. X minus x is what? It's not a trick question. X minus x is 0. Negative 4 minus 7 is negative 11. Is everybody good with differences of squares? I think you're liars. There's one last kind. What about this? E x to the 8th minus $256. Oh, nasty. Nothing changes.
How long does it go on?
How long does what go on? My whistling?
I mean, this song that never ends.
That wasn't the song that never ends.
The first part that I actually listened to definitely was. If you were improvising, then you were improvising that.
All right. Once again, some people recognize that 256 is 2 to the 8th, right?
Mm-hmm.
Which means it breaks down into square roots, doesn't it? And x to the 8th breaks down into square roots, doesn't it? So what is the square root of x to the 8th? X to the 4th. Plus, what is the square root of 256? 16. And then I do the same thing. X to the 4th minus 16. Am I done? Why not? Because that's got a square root and that's got a square root, doesn't it? So I have x to the 4th plus 16, x squared plus 4, x squared minus 4. Am I done? No, why? I'm going to do the same thing with the 4s. X plus 2, x minus 2. Now am I done? Because you can't do anything with addition. So the answer is x to the 4th plus 16, x squared plus 4. Is everybody good? That's every permutation I can think of for difference of squares. Yeah. Is everybody good? The only other thing that we do to mess you up is we make the last number 1. X to the 8th minus 1. 1 always gets smaller, yes? It's always minus 1, minus 1, minus 1, minus, right? Because 1 times 1 is still 1. That's the only thing we do to mess you up. That is every possibility that I can think of for difference of squares, which I usually say I can't possibly do that, but I think I have done it. Well, then it would just be x to the 8th minus 0, so you would just be factoring x to the 8th, which is already factored. You're an interesting cat, Nav. All right, now we get to number 4, the one that nobody can do, which is why I have left an entire page. We'll start with, we're going to do one trinomial, we're going to work it all the way through. 3x squared plus 8x plus 4. You cannot GCF that, so you're stuck with the 3, right? Now, I was taught one way to do this. I started teaching math, none of my students understood that way. I learned a second way to do this. I have 2 ways to do these. About halfway through my math teaching career, some exchange students factored this with a third way, a different way that I had never seen before. I don't remember how to do that, so I'm going to ask if one of our exchange students or any of you have seen that way, because I don't really remember how to do it. But I do remember the first 2 ways. So I'm going to show you 2 ways to do this that I know. You can choose which one you like better. And then I'm going to ask if anybody else knows the third way. Okay? So this is the way I like to do these. And I'm going to work in red. I'm going to call this method 1. A, B, C. A times C. That's step 1. So that equals 12 in this case. So I need numbers that multiply to 12 and add to 8, right? Cool? So step 2, I then set it up the way I already know how to do it. X plus X plus. Why did I know they were both addition? Because they were both addition up here. What are the factors that add to multiply to 12 and add to 8? Plus 6 plus 2. Now, how did I get 12? I multiplied 3 by 4, yes? So at some point when I'm factoring, I have to remember that I have to divide, right? So I divide these by 3. Step 3 is simplify. What is 6 divided by 3? X plus 2. This doesn't simplify, so denominators move to the front. And I get 3x plus 2. Then I check it. Is x times 3x squared? Yes. Is 2 times 2 4? Yes. If the first and last work, the middle works. And that is done. Does everybody remember seeing that in the past from somebody?
Where'd you get the 3 to divide by?
I started with the 3. I multiplied that 3 over there. So I have never gotten rid of that 3. Right? Until right here.
Gotcha.
Okay? This I learned from an Australian math website.
So it's just
Australians factor this way. Is everybody cool with that?
Australians and Myers.
Okay. Now, there's another way to do this. That's no good. There's another way to do this, which I'm going to now go with black here. You start with the same way. Step 1 is still A times C. Step 2 is still factors of A times C that add to B. Step 3 is we rewrite that. So it was going to be 3x squared plus 6x plus 2x plus 4. Everybody cool here? 3x, 3x, 2 plus 6, 8, 4. Everybody good? Then you do this. Group and GCF. Group that, group that. What is the GCF here? 3x. And that left in there x plus 2, correct? What is the GCF here? 2. And that left in there x plus 2. Then we factor that. We GCF again. And we get 3x plus 2 times x plus 2. I don't care what you do with this. I'm going to show you another way to do this in a minute, I hope.
That was way harder.
This is the way I learned. This is what I was taught in the 11th grade. It's called decomposition. I don't mind using it. You don't have to, but it can come in handy later on to have seen it. This, I don't know what they call it. I got it from an Australian website. I'm going to assume it was invented by some Australian math teacher. I have no idea. Okay? Kelvin. Well, those were the factors, 6 and 2 of 12, that added to 8. Okay? It's just rewritten. Now, there's a third method, which I have seen done. It was done, first time I saw it was like 6 years ago by a Korean exchange student. And they made a box. And they put numbers in the boxes, and they like the factors of 4 are 2 and 2. And then, like, I don't even know how to do it. Then you go across. So it's 3x plus 2 and x plus 2, because you go across.
Should that was last year. So.
Yeah, I don't know exactly how it works. Do any of you? I don't like this way because it's guessing, right? If you're going to just guess, why are you here? Because 4 works nicely, right? It's only 1 and 4 or 2 and 2. So you would try 3 and 1 and 4 and 1. 3 times 1 is 3. 1 times 4 is 4. So that one doesn't work because they would both have to be positive. So you would do this. Then you would have 4 plus 3. That's 7, so it doesn't work. In this one, it's 6 plus 2. Oh, that's 8, so it does work. And then you get your answer by going across here. I don't like it, but some kids do, so I show it to them. If that works for you, guessing, because that's really all that is. It's guess and check. Go ahead. I don't care which one you use. Did any of you guys get taught this? You did? Can you explain it better than me? Because I wasn't taught it. It's just, but it just comes down to guessing and checking, right? Okay, good. Help me out. Let me write another one. You can run it through for us, okay? Let me write another one. Let's go with 10x squared. Hey. Okay. 8 plus, no, let's go minus 8 plus 11x. So how would you do that with the 4-box method? What would you do? Because honestly, I don't know. I'm not trying to be mean. I had just never seen it before, and I don't like it, so I don't use it. So what would you do there? Okay, so this side of the box has to be 2 and 4. But one of them has to be negative, right? The 10 has to be 2 and 5. But couldn't the 10 also be 5 and 2? Okay, and couldn't this also be 4 and 2? And couldn't that be negative and that negative, or that positive and that like, see what I mean? Like, I don't like it because there's so many chances. But I'm going to shut up and let Jungwoo talk. Go. What would you do? So I go 5 and 2. So you're just arbitrarily choosing 5 and 2 instead of 2 and 5. That's all I'm asking. I'm just asking, how do you know to put 5 on top or 2 on top? You can have all the time you need because you're teaching me. I don't think she would want to, from what I know of Jungwoo. Would you like the magic pen, Jungwoo? See? I know my audience. So anybody who has seen this is welcome to take over here.
I like vaguely remember, but not enough to do it.
Okay, so what is it? What? You ready for the magic pen? Sweet! Yeah, she wanted to make sure she had it right before she came to the pen, though.
Oh, my hands are like trembling.
I know, it's not easy.
Scary.
So now what's the answer?
Is this right? It's what? Okay, it's not.
That's positive 8 and negative 1.
What? Why?
Positive.
Oh, okay.
Run the magic pen.
Yes.
Yes. Okay. Now, everyone, she has done wonderful work here, but you will notice she seems to have gotten it in one try. Right? Now, if you look at her actual paper, and I'm not putting you down, there is a few trial and errors there. Okay? That's why I don't like this. Because you can make educated guesses, but in the long run, it's a trial and error thing, right? So, oh crap, what was it? 10x squared plus 11? Plus 11x minus 8, right? So Peter, can I look at you did the box? So, like, how did you know to use 2 on the top and negative 1 on the top? Or did you just...
Always all about practice.
It's just from practice, right? Yeah. So, what Peter did, and what Jungwoo did, and I'm not putting her down in any way, is... just from looking at it and doing so much binomial expansion, you start to see, okay, well, I know that's probably going to be 2 and 5. Again, order doesn't really matter. And that's either going to be 4 and 2 or 8 and 1. That's the only options, yes? So you quickly check. Now, Peter went with 8 and 1, right? And then one of them had to be negative, right? So you just check in your head, okay, well, 2 times 1, that's 2. 5 times 8 is negative 40. Oh, that's not going to give me 11. So I got to change to here. Change the negative down there. 2 times 1 is negative 2. 5. Oh, wait, that doesn't work either. 5 is still 40. So I can't have 5 with 8, yeah? So I change this to 1 and 8. Now 2 times 8 gets me 16, positive 16. And 5 and 1 gets me 5. Oh, that'll get me 11. So here's where the negative has to be, right? And then I get 2x minus 1 and 5x plus 8. Okay? I don't care what you do. I couldn't care less. Whatever way you want. But you gotta be good at one of them. It's good to be good at all three, just in case, right? Everybody okay? Yes? One of those 3 things works for you? Okay, then your homework, which will not be done or due for me until Monday, because tomorrow is test day and Friday you're not here, is up to, for me it's page 62. Is it page 62 for you guys? Factoring a summer difference of cubes? Yes, sir. Okay, up to 62 is due. Okay? So go diddly-o.